Hey there, I'm Mitchell and welcome to another video in the RSP educational series. Today we're going to talk about basic electrical elements and how electricity powers everything in industrial automation, from tiny sensors to massive motors. But do you really understand the fundamental building blocks behind it? If you want to master electrical systems, you need to know volts, amps, ohms, watts, joules, etc. In this video, we're going to discuss specifically voltage, how it's crucial to the foundation of electrical flow. Whether you're troubleshooting automation equipment or designing industrial control panels, understanding these concepts is critical to working with electrical systems. As always, if you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Always consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So voltage is electrical pressure that pushes current. You'll also see it abbreviated as a V, or volts. In industrial automation, voltage is a critical parameter that determines the operation and safety of control systems, motors, sensors, and power distribution networks. It's the driving force behind electrical signals and power delivery that ensures that automated systems are going to function reliably. But an important concept to grasp is that voltage is always relative. It's measured between 2 points, not at a single location. A voltage of 120 volts in an electrical system means that one point is 120 volts higher than another point, usually ground or neutral. So for example, a 9-volt battery. This means that the positive terminal is 9 volts higher than the negative terminal. In a 120-volt outlet, this means that the hot wire is 120 volts higher than neutral or ground. Think of it this way. Voltage is like pressure in a water hose. Imagine you have a hose connected to a water tank. The more water in the tank, the higher the pressure pushing the water through the hose. If you open the nozzle, water flows out because of this pressure. But just like too much water, it can burst a hose. Same with too much voltage. It can actually damage electrical devices. That's why we use the right voltage for different applications. So in automation, electrical power is supplied at different voltage levels depending on the application. Some common ratings for low voltage are 24 volt DC or 120 volt AC or 240 volt AC. These are used for control circuits, PLCs, sensors, actuators. For example, a 24 volt DC power supply provides control power to a PLC or programmable logic controller in a control panel. Now let's discuss AC versus DC voltage, how they work and why they matter. Electricity is delivered in two different forms, alternating current, AC, and direct current, DC. They do behave differently though, which makes each useful in different applications. Direct current, DC, flows in one direction. It's a steady flow. DC voltage provides a constant voltage level, flowing in a single direction like water in a straight pipe. An example of this would be a 24 volt DC sensor in an automation panel receiving a steady voltage, ensuring reliable operation. Alternating current, on the other hand, AC, changes direction periodically. AC voltage reverses direction at a specific frequency. For example, 60 times per second in the US or 60 hertz. The reason or applications where this is used or why it's used is because AC is better for transmitting power over longer distances with less energy loss. Common uses are going to be power grids, industrial equipment, high voltage motors. For example, a 480 volt AC motor in a manufacturing plant runs on alternating current because it's efficient for large loads. Understanding the difference between AC and DC is critical in industrial automation because different systems require different power types, as we just discussed. For example, sensors and PLCs, a lot lower power, they often run on DC, while motors and transformers, a lot higher power demand, they typically operate on AC. Now let's discuss voltage and motor control. Variable frequency drives, we love to talk about these, VFDs, and soft starters. They adjust motor speed and torque by regulating voltage and frequency. For example, a VFD is going to lower its voltage when starting a pump to reduce inrush current and prevent damage. Motor starters and contactors, they also use control voltage, typically 24 volt DC or 120 volt AC, to switch higher power circuits like 480 volt AC on and off. For example, a contactor in an MCC energizes a 480 volt motor using a 24 volt control circuit. So some considerations around voltage in industrial automation. One of those is going to be voltage drop. Long cable runs in a facility can lead to voltage drops, and this is going to require thicker cables or local power sources. Also, we want to make sure that isolation and protection is included in systems. Things like surge protectors, fuses, circuit breakers, these all prevent damage from voltage spikes. Power quality is another concern. Automation systems are often going to use UPSs or uninterruptible power supplies or industrial power conditioners to maintain stable voltage levels. Safety is another consideration. Higher voltages are going to require lockout, tagout, or LOTO procedures and personal protective equipment. In industrial automation, voltage determines power availability, control signal integrity, equipment operation, whether it's 24 volt DC for PLCs, 124 volt AC for control circuits, or 480 volt AC for motors. Understanding voltage is going to ensure proper system design, troubleshooting, and safety. That wraps up our dive into voltage for now, one of the most fundamental concepts in electrical systems, but this is just the beginning. This is the first video in our foundational concept series where we'll break down the essential elements of electricity, like amps, ohms, watts, joules, and more. Each of these play a crucial role in industrial automation control systems and power distribution systems. As always, for hundreds of thousands of other industrial automation products, please go to our website. Also, for more information and other educational videos, same thing. Go to rspsupply.com, the internet's top source for industrial hardware.